Discuss example number 8. Divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square and verify the division algorithm. So first part, we have to divide the polynomial and then you have to verify the division algorithm as well. So the question has two parts. Solution: to perform the division, we are going to use the division algorithm and then verify it. So first of all, we are going to do the division part and then do the verification part. So moving on. Note that the given polynomials are not in the standard form. So it is very essential to know that the given polynomial should always be in the standard form. That is, they should have the terms in descending order or decreasing order of degree. So here, to carry out division, we will first write both the dividend and the divisor in decreasing orders of their degrees. So first of all, we are going to do this process and then do the division thing. So when you write the dividend in the standard form, you get minus x cube plus 3x square minus 3x plus 5. And when you do the same for the divisor, you get minus x square plus x minus 1. So now both of them are in the standard form and we can apply the division algorithm. So let's see how we are going to do that. So here in this picture, you can see that we have applied the division algorithm and division process is shown on the right side. So quotient is x minus 2 and the remainder is 3. So x minus 2 here is the quotient and 3 is the remainder. You can see that this arrow is pointing towards the quotient and this one to the remainder. We stop here since degree of 3 is equal to 0, which is less than 2, which is equal to the degree of minus x square plus x minus 1. So what this statement is actually trying to say is that the degree of the remainder has become, less than the degree of the divisor, or the remainder becomes 0. So here degree would be 0 for 3 and degree of this divisor is 2, and hence we stop the division. So now you can see that this was the division process and here we have applied the division algorithm in a step-by-step manner, and the next thing which we are going to do is the verification part. So divisor into quotient plus remainder is the one side of the division algorithm and the other side is the dividend. But what we are going to do is that we are going to put in the values of each of these terms and try to see if we get the dividend back. So this is the divisor, this is the quotient, and this is the remainder. And when we simplify these, finally we are getting minus x cube plus 3x square minus 3x plus 5, which is the dividend, and in this way the division algorithm is verified. So you can see that here we have done the verification part, and what we have done is that we have taken one side of the general formula and we have put in the values and then we have reached to the dividend part. So this is a very interesting way to verify the division algorithm, and I hope that you are going to use this method. So I hope now that I have clarified this particular example for you and you were able to grasp all the different concepts that were involved in solving this particular example. So now let's take a look at some tips and tricks which are going to help you solve similar type of problems. So first of all, always use pen and paper to solve these problems. So to get the right answers and make less errors, use pen and paper. Check your calculations. Checking your calculations is very important because you might make errors in small calculations, in small additions and subtractions and multiplications. So try to recheck your calculations because it's going to help you in getting the right answer. And thirdly, use this property for verifying your answer. So in this question, we actually had to use this property. It was mentioned in the question to verify, but It is very essential that you remember this property because it was not mentioned in the question. So this is a very important property and I hope that you will remember it. Also, I hope that you had fun in watching this video and you enjoyed this video. So thank you so much for watching today.